Here we go with 4.17, construct trigonometric functions to model given situations. So this is going to be the last video that we do on creating trigonometric functions to model real-world situations. We're going to do a couple more examples tomorrow to get ourselves prepped and ready to go. And then we're going to cover a couple of advanced trigonometric properties before we move on to the unit test. So remember that we have a quiz tomorrow, so you'll want to make sure that you give these problems lots of time and some work to prepare yourself. I also want to mention one more thing, which is that your question and or comment, if it is a question, it needs to be specific. Okay? So if you have a question like, how do I find phase shift? Well, go back and watch that video. If you have a question about finding the phase shift on this particular question, you need to describe the process you took, give your best guess, based on what I did, here's what I think the phase shift should be. I'm not sure if this was the right step, can someone help me? Right? And so that is the type of question that we need to ask, and so make sure that your questions are specific. All right, let's go ahead and take a look at some of these tasks. Here's the foxes and rabbits situation that we were dealing with yesterday. And what we want to do is finish this up. So you want to complete the functions that you're writing for B and C. And remember, our goal is to try and do it without creating a graph of the data. So if you can, give B and C a try without creating a graph. And then if you need to, go ahead and graph the data and use that to construct your function. Then part D, we want to graph both functions on the same graph and try and give an explanation as to why it seems that one function is chasing the other function. Okay, so go ahead and pause the video, finish that up, and we'll talk briefly about that before moving on to an extension of this. All right, so first starting with rabbits, we'll go ahead and do this rabbit population. We'll use blue here. So rabbits as a function of time. And what I want to think about is just sort of what is this data doing? Well, it starts off at 1,000, and I'll notice that 1,000 is neither the maximum or the minimum. In fact, the minimum value that I have is 500, and the maximum value that I have is 1,500, which helps me to realize that in the middle is going to be 1,000. So my function is beginning at the midline. Its minimum is 500 and its maximum is 1,500, and so that gives me the amplitude. So I have an amplitude of 500, and I'll leave whether it's going to be sine or cosine blank for a second, because we also know that the midline is going to be at 1,000. Okay. And now I want to consider what sort of a function I should use here, sine or cosine. So noticing that it begins at the midline will tip me off to the fact that it would make a lot of sense to begin to use a sine function, because a sine function with no phase shift will begin at the midline. And I also want to consider that what is happening after my initial point. We'll notice that values are decreasing. Okay, so just to visualize here, if I have a sine function, it begins at the midline and then increases. Okay? And here we want to begin at the midline, but we want to decrease. So if you'll notice, if I'm following this pattern here, beginning at the midline, it's decreasing up until 3 months. And then it starts to increase again back to 1,000. So if I think about it, I'm decreasing, then it starts to increase back to 1,000, the midline again, and it continues increasing to 1,500 and then decreasing again. So what I want to do is I want to reflect this sine function, so I want to make this a negative sine function. And then the last thing I need to figure out is what is the period of this data? And we might just immediately realize, look, we're dealing with a calendar year, and so it makes sense that I'm going to be hitting my minimum again or my maximum again 12 months later. And so if my period is going to be 12, I'll just solve this briefly. So if my period is 12, I know the period is 2 pi over the absolute value of b. And so what will the value of b equal? Well, I can multiply by b on both sides. We'll just imagine this is a positive number. We'll just let b be a positive number. And when I multiply by b on both sides, I get b times 12 equals 2 pi, which means that b is equivalent to 2 pi over 12, which is pi over 6. Pi over 6. And my independent variable is, of course, t, so I'm multiplying by t. All right. Now, for the foxes, we have a slightly different situation, nothing too crazy. So if I'm looking at f of t, and I just start to look at the data, I will notice, of course, that I'm beginning at 150, which appears to be the maximum value that occurs over the 12 months. So I'm starting off at a maximum value, and then the function, the data starts to decrease all the way to a minimum of 50. So that right there pretty much tells me everything I need to know. Min is 50, max is 150, so my amplitude is 50. My midline will then be 100. And I'm beginning at the maximum and decreasing, which works just like a cosine function. So I have cosine, and period should again be 12 months, so pi over 6 times t, and there's no phase shift because it's beginning right at a maximum value. So those are my two functions. I'm going to show you the graphs in just a second. If you haven't already, go ahead and construct a graph of both of these on the same graph so you can sort of look at how one is chasing the other. Here are the graphs of the functions, and the dots, the points, represent the actual data, right? So remember, at 0 months there was exactly 1,000 rabbits. At 6 months there was exactly 1,000 rabbits again. At 9 months there was 1,500 rabbits. And notice that our data and the function match up perfectly, right? They end up matching exactly perfectly, and the same with the fox population. Okay, and I can see here obviously that this is a sine function. Here's the midline. The sine function is decreasing because it's negative, so everything is reflected. Imagine if it were not. So if this were not a negative sine function, it would look more like that. And of course it does not, so it's reflected. And then similar here for the fox population. Here's my midline, starts at a maximum, decreases, and then returns back. And if I were to graph both these on the same graph, notice, of course, that the rabbit population is much greater than the fox population. But there still seems to be a little bit of a correlation, right? Notice that the rabbit population, right, is decreasing, right? The rabbit population is decreasing, and that decrease happens right before the fox population decreases. When the fox population decreases, right, all of a sudden the rabbit population starts to increase. Then, as the fox population starts to increase, the rabbit population starts to decrease. Again, as the fox population starts to decrease, the rabbit population starts to increase, right? And that should make sense. I'm not going to talk about it too much because I want you to put it in your own words. One thing I want you to notice is that this data fit perfectly, right? There was no, it was very clear what our midline, what our min and our max were, and they worked out just perfectly. And in real life, this may or may not be the case. In fact, in most situations, this is not going to be the case. So what we're going to do now is we're going to look at a more realistic situation, and here we're going to have to make some decisions on our own about how we're going to construct our function. So let's take a look. All right, so here we have data plots for the population of foxes and rabbits over a 24-month period. Rabbits and foxes, okay? And what I would like you to do right now is go ahead and pause the video, give A, B, C, and D a try. Make sure that you are working through this with the intent, look, I'm practicing for a test, and so I want to make sure that I'm giving this my best shot, and we'll discuss briefly at the end, but I'm not going to say too much. Okay, I hope that went well. What you'll notice as you look at this data is it's not perfect, right? There are little fluctuations here and there. But overall, the data seems to be following a pattern, right? Now, they may be a little different from one year to the next, right? May not exactly work out how we predict it, but if I were to if I wanted to approximate the rabbit population, if I wanted to fit a model to it, I'm going to want something that's repeating this pattern, right? Or the fox population is repeating this pattern. And so I want to use a trigonometric function, either a sine or cosine function, that will help model this repeating pattern. All right, so in your comment, your question, or your answer, I want you to include your answer to part B. So you should be including your function r of t and your function f of t that you created. Okay, so include both of those and make sure that your question, if you ask one, that your question is very specific. So your question should be specific to this question or the question that we just did. Of course, if your question is, how do I find phase shift? Well, then you should go back and you should watch that video. So don't forget to do that. This will be great prep for the quiz tomorrow. Have a good night, and we'll see you soon.